So today we did a repair and put these teeth that were worn down on a press brake. This is the engaging teeth. And after we did the repair out of mild steel, we're now going to do a surface heat treating compound to harden the surface. So we're going to surface harden it. Right now we're getting it up to a nice red cherry temperature. At this point we'll apply the surface hardening agent, which we like to use cherry red. And that'll stick to the surface. And then we'll heat it up again until it's red. And that will complete the process.
I think it's really red. And you got the one that's working, right? What do you want me to do? Is this very hot?
What? Yeah, hot.
Really, really nice.
You can see how it's applied, kind of glasses over. This is the heat treating part. I bring it up to red again, making it really bright. Now with the addition of the surface heat treating compound. Also want to do this in a well ventilated area. It's stinky. But this will surface harden and make the teeth soft on the inside, but give it a wear surface on the outside. And we've got to bring it at temperature. You can see how it makes the torch much brighter. And that's the surface heat treating the cherry red compound and doing its job, passing over. And as we heat the metal to the red temperature, it slowly penetrates the outer oxide surface, or the outer surface, and penetrates so many mils deep to give it a hardened wear area. Not only does it surface harden the areas that we want, but it also helps normalize the heat affected zone after welding and building up the surface. So it does two things for us here by heating it. Right now, this glass that you see on there, as it cools down, it will chip off and it'll come back to its original surface quality and finish, which was shiny, but it's got to cool down. And with this material, you can quench it if you want, or you can let it cool naturally. We're going to let it cool naturally, just because I'm not looking to introduce any other stresses into the material anywhere else. We're just going to let it air cool at its current condition until room temperature. From there, we'll show you how we work it clean again and get the glass off of it, make it look back brand new. So here we are with the final product after surface hardening and treating the gear teeth. Part's all prepped, everything's clean. We got all the glass off from surface hardening, cleaned it all up, and ready for customer pickup. Process for this when it came in is all the teeth were sheared off, so we preheated it and then did welding passes and built up all this material that high with weld. Then we heated it, normalized the heat affected zone, and this is mild still even, but just as a precautionary. And then we cut the new involute gears to match the profile given by the customer, which the best way to do that is take a clay imprint, just using basic Play-Doh. And because the gear was not able to take off the machine, but it does help to make sure the mesh fits and everything. So he took an impression with Play-Doh, and we had that as a way to check along with the specs of the gear. And popped it out, looked good, surface hardened the teeth for him, and ready to ship. Another successful job.